I'm here today in my capacity as Non-Executive Director of Interlligent UK. For the avoidance of doubt, I'm still the CEO of Plextek RFI. I've not switched ships completely. Interlligent UK provide test equipment, RF and microwave test equipment. So if you have any requirement for your development or your production test, you know where to go. So I'd like to start by looking at where we've come from and where we've got to. This is Kurtz, a man so famous he gets to be featured on a stamp. Now, he died at the age of 36, but he contributed quite a lot to science and technology, not least a series of experiments he did between 1886 and 1889, when he proved that you could transmit radio waves. Electromagnetic waves could propagate through free space. And on that stamp, you'll see two bits of equipment, and they are part of his setup. And this is a photograph from his lab. And the two balls there, they're zinc spheres, and they're either end of a 1 meter piece of copper wire with a gap in the middle, and that's a dipole. And the ring to the right is his receiving antenna. This is a little simple block diagram. And what he did was to take an induction coil and to put it across that dipole, generate a spark, which generated a standing wave, and it was received by his receive antenna over on the right. And it was about 100 megahertz, his transmission frequency. And people afterwards said, "So, Hertz, what's it for, this?" And he said, "It's of no use whatsoever. It's just a simple experiment to prove that Maestro Maxwell was right." Well, that turned out to be something of an understatement. So from 1889, 30 years later, we had the first commercial broadcasting station. Not the BBC, but it was in The Hague at about 500 kilohertz. Then, 25, John Logie Baird transmits TV signals. 11 years later, the BBC has the first world's commercial broadcast television service. 3 hours programming a day. It's probably plenty. There weren't many TV sets around, to be absolutely honest. Not many repeats either. 1947, the transistor was invented at Bell Labs. People did think that it wouldn't replace the valve, but they were wrong. It moved on to the transistor radio in 1954. The integrated circuit was invented in 1958. And this was really the catalyst for the reduction in size and the increase of complexity that make today's wireless communication devices possible. We launched the first geostationary communication satellites in 1964. 1970 was the first microprocessor, another great innovation that's used extensively. The first cellular car phone service was in Japan in 1979. Had to be a car phone because it was so big and power hungry that you need two men to operate it. Then the first proper cellular telephony service was launched in 1981. This was first generation. It was really FM radio. They didn't call it first generation at the time. They probably wouldn't have believed we were now going to be speaking about 5 generation. The first hand portable device in 1983. GPS constellation of satellites was commenced in 1987. And today, many people couldn't get by without them. GSM commenced in 1991. This was second generation cellular. Originally it stood for Groupe Spécial Mobile, but in the interest of world domination, they changed the name for Global System for Mobile Communications. Then 3G operations started in around 2003. 4G round about 2009, depending exactly what you consider to be 4G. So what's next? 5G, Internet of Things. Well, 5G, there's a lot of research effort being put into 5G at the moment, and we've heard a lot about it already. But realistically, the system's not going to be rolled out till 2020. People have spent a lot of money on 4G, and I can promise you they're going to want to recoup some of that. Internet of Things is already here. This picture was given to me by a company called Talenza, and they have a wireless street lighting system. And where I live in Cambridge, these are on top of all of the lights. Every lamppost in Cambridge has more computing power than the first manned mission to the moon. And they're being rolled out in Essex and other parts of the UK, and they're starting to roll out in America and in Australia. And it's very successful. And what happens is every 1,000, 2,000 lampposts, you stick one of these boxes with a big antenna on, and that's the base station. That communicates back to the internet, and with an appropriately commissioned smartphone and the right approvals, you can turn off street lights with your smartphone. This allows you to save electricity, which the local authorities like. It also allows you to monitor the amount of electricity you're using. Previously, the street lighting authorities just had to give money to the electricity company and assume that they'd got it right. So, how far will the Internet of Things go? Well, this includes a collection of images across the bottom. Some of them already exist. Some of them may exist. Some of them are pipe dreams. The one on the left is a blood tester. This is real. People could test their blood, and it communicates back to their smartphone, either with NFC or with Bluetooth, and then it transmits it back to the medical monitor, and it's for diabetes monitoring and management. The wine bottle, this signifies Internet of Things connected food products. So why would you do this? Well, it could be for sell-by dates, restocking, alcohol intake monitoring. Not sure how popular that one would be. The next one is an Oral-B toothbrush that connects to the smartphone for monitoring of toothbrushing length and accuracy. And that exists. The Tesla smart car, the electric car, this exists. Connects to the internet for uploading updates and smart maths. I'm not sure how comfortable I'd feel with a car that paused to install important updates, but it is there, it's real. The cow is livestock tagging. This really happens today. At the moment, it's read with handheld readers, but why not direct to the internet? The fridge, people who work in the Internet of Things development, they hate the fridge. They hate this example because everyone talks about it. The fridge automatically orders stuff for you. I think this is something of a pipe dream. The trainer, that's a Nike model, very popular for people standing at the bar and playing pool. And that has a connecting device to your smartphone, and it will detect how much exercise you get. And agricultural, for monitoring of crops and irrigation management. So wearable connectivity, a fitness band. This is an actual fitness band. My colleague Andy Dern has. He took a photograph of it, and he wears it, and it communicates with his smartphone and tells him how much he's moving around. Smartwatches. You've probably seen this model. Other smartwatches are available. This is fantastic for people who've spent 600 quid on a smartphone and are looking for something to spend another 300 quid on. This is absolutely great. I highly recommend it. Smart rings. So this is a Moto smart ring, NFC connected, and it connects to your devices, and it tells you how many emails you've received. How we manage without it, I don't know. This is a virtual reality headset. Now, gaming is the most commonly known use of these, but actually they do have some sensible, more laudable uses. Things like teaching people surgery without so much risk of damaging people. And remote patient monitoring. As our population continues to stubbornly age, this will become increasingly important both to society and to manufacturers. Things like dementia management, monitoring of falls, so that people can continue to live in their home rather than going into residential care. Heart and temperature monitoring. This is a device, clip it on, monitors the person's temperature and their heart rate, and you can real-time check everything's great. And a similar device for monitoring blood pressure. So in summary, wearable connectivity and the Internet of Things is already here, but there's still lots of development going on. There are lots more applications out there, and I'm sure some of my co-presenters will regale us with what's going to happen. Thank you.